All right, today I'm going to be going through multiplying polynomials. Now, one thing I want to emphasize, this is a common mistake a lot of people make. This only works when you're multiplying polynomials. If you look in this case, I've already done this twice because I forgot to turn on my mic last time, so bear with me. I have two polynomials, two trinomials to be exact. Separating them, I have an addition sign. I would be adding these polynomials. So the method I'm about to teach you would not work for this. And likewise, you'll notice down here, once again, I have two polynomials. Right here and right here. Between them, I have a subtraction sign. Guess what? This method would not work for this either because I'd be subtracting these polynomials. This only works when you're multiplying them. So in this case, let's take a look. We got two polynomials. As a matter of fact, we've got a binomial, which is two terms, and a trinomial, which is three terms. We don't have any operations between our grouping symbols, which means we're going to be using multiplication. Here's a trick. Someone taught me this. I hate to say a trick. It's just a nice method to keep things organized. One thing you want to consider, you're looking at this as terms. So instead of thinking of x minus 3, think of this as x and negative 3. What I'm going to do is I'm going to take these two terms and I'm going to write them out like this. I'm just going to do them vertically. Next, I'm going to take the next terms. I have negative x squared, which I'm going to write here. I have positive 2x, so I'm going to write 2x here. Then I've got positive 4, so I'm going to write 4 right here. Now, what I'm going to do is I'm going to make some boxes here. I'm going to create two rows here for the x and the minus 3, or the negative 3 rather. And I'm going to create columns for each of these terms. I'm going to create a column for negative x squared, for 2x, and for 4. Now, how do I go about multiplying this? I'm going to multiply the corresponding terms for each box. So you'll notice here, I have x in this row, and then for my column, I have negative x squared. So I would multiply these two terms. One thing that's helpful, if they don't have coefficients, you can always put a 1 there. So I would do 1 times negative 1, which is going to give me negative 1. X to the first times x to the second is going to give me x to the third. So I multiplied those two terms out. I'm going to highlight this because I'm going to need that term in the long run. Now I'm going to multiply x again, or 1x to the first, right? I'm going to be using that x that's in that row. I'm going to multiply it by 2x this time, times 2x. When I multiply that out, I'm going to get 2x to the second. Next, I'm going to use x again because that's the x row right here. I'm going to multiply it by 4 because 4 is up here in the column. And that will give me 4x. So now I've got 3 new terms. Next, I'm going to go to this row where I've got negative 3. I'm going to do negative 3. And then I've got negative x squared. So I'm going to multiply it by negative x squared. I'm going to make negative 1x squared. That can be helpful. Because now I have negative 3 times negative 1 gives me positive 3x squared. I'm going to highlight that because I got a new term here. I'm going to use that negative 3 again because I'm in the negative 3 row. I'm going to multiply it times 2x. Multiply those out. I get negative 6x, which I am now going to highlight. All right, I'm going to keep it going. Since I'm in my negative 3 row, I'm going to do negative 3. And I'm going to use 4 because it's in the 4 column. Negative 3 times 4 gives me negative 12. So now I have all these new terms that I can deal with. And now I'm going to erase the operations because I want to show you something cool that happens when you do this. I did not realize this initially. A fellow teacher shared this with me, and I said, hey, that's pretty neat. It's a great way to organize stuff. So I'm just going to get rid of the operations. A lot of people, once they get comfortable with it, they just do the operations in their head, and that's fine. You don't have to write them out in every box. I just wrote them out initially so you could see where the stuff was coming from. Now watch this. The terms are diagonal from each other, right? They are always going to be like terms. It's pretty cool. It can help you keep things organized. So you notice negative 1x to the third doesn't share any like terms. There's nothing that shares x to the third as an exponent. However, 3x squared, 2x squared, those are common. Those are, they've common exponents. They're like terms. Negative 6x, positive 4x, again, like terms. And then minus 12, it's a constant term all on its own. Now I can just combine my like terms. I'm going to get rid of the 1 here. I don't necessarily need it, so I'm just going to make it negative x to the third. 3x squared plus 2x squared gives me 5x squared. Notice that I didn't add my exponents. That only happens when you multiply. So, check your exponent rules if you're a little fuzzy on that. Negative 6x plus 4x, that's going to give me negative 2x. Whoops. And then last but not least, my constant term, negative 12. And I now have a new polynomial. So multiplying two polynomials, you should be getting an answer that looks something like this. So again, what do you do for this method? Deal with each term individually. Start with your first polynomial. Those terms become your column right here. And then your next polynomial, spread out those terms up here. And then you just multiply them out. X times negative x squared, x times 2x, x times 4, negative 3 times negative x squared, negative 3 times 2x, negative 3 times 4. You can recognize the like terms by going diagonally like so. You don't have to. But then you just combine all these terms, combine your like terms, and you get a new polynomial. And remember, that only works for multiplication. That will not work when you have subtraction, when you're subtracting polynomials. When you have a subtraction sign between those grouping symbols. It will also not work when you're adding those polynomials, when you have an addition sign between those polynomials. This only works when you're multiplying. Hopefully this helps you, and best of luck.